So welcome to the December.NET user group. It's great to see you all guys here today. And today we're going to be talking about IoT. So I'm going to kick things off with Windows Internet of Things development. My name is Chris Briggs, Senior Software Developer at SSW. Now today, our agenda, we've got three parts to our talk. The first is we're going to create and deploy a universal Windows application. We're then going to connect to a hardware sensor. And lastly, we're going to communicate with Azure. So, what is the Internet of Things? Don't feel bad if you don't really know what this is. So recently they went out and did a survey to see what the consumer adoption of it would be like. And they found that 87% of the people who they surveyed had no idea what IoT was. So I'm going to give you guys a brief overview just to get you started. So IoT means a device that collects and transmits data via the internet. Now, actually, they've existed since the 70s when you really think about it, with the first ATM machines. And then we go forward a bit, and in 2008, we found out that there were more things on the internet than actually people using the internet. A couple more years forward, we start seeing real commercial investment. So Google buys a company called Nest, and they're all about smart homes. And then connect them all back to a central brain that makes decisions for you based on conditions. And then this year, we've seen the rise of wearables. So it's grown by over 200%. And recently I was at the Yale Connect conference in Melbourne, and it was the hot topic that everyone was talking about, was wearables and how to really take advantage of them with IoT. So just a quick question. Who thinks which of the devices sold the most? I already told you this morning, you don't count. Fitbit? Yeah, so Fitbits, surprisingly, they've sold 4.4 million units. Now that's closely followed by the Apple Watch at 3.6, which is really kind of crazy if you think about it. Fitbits have been out for at least a year and the Apple Watch only a couple months. And already they've sold together 8 million units. Now sadly, we don't know what the Microsoft Band 2s have sold yet. Hopefully they'll be as higher numbers. But by 2020, 250 million vehicles on our road will basically be our IoT devices. Now, if you make a car smart, sadly that doesn't stop pranks happening. It only just gives you more information to make informed decisions. And over the next 20 years, we're going to see $10 to $15 trillion worth of GDP just from IoT alone. Now, IoT can be used for a number of things, for cars and for making trillions of dollars in GDP. But it's also good for children's assignments. So Ruby here had an electrical assignment, and she had to go and demonstrate power and switches and circuits and light bulbs. So what did she come up with? She wanted to build a high striker game. That game you see at carnivals that you smack down with a mallet and it causes something to fly up. Now this was a really interesting challenge, and of course SSW being full of big geeks and kids at heart, we jumped on to give her a hand. So version 1 was powered by an Arduino, and sadly we didn't really understand the need for structural engineering when building something was going to be smacked with a hammer all day long. So she takes it to her school, and what happens? Well, she single-handedly basically derails the event. All the kids leave their stands and line up in front of the Pi Striker, smacking it with a mallet over and over and over again for the entire day. And so if you actually have a look at this, you can see in the timber where it's been shredded by the repeated bashing from the kids on the metal bolt. So it comes back to us. It's basically in pieces, and the school said, hey, we've got a family fun night coming up. Can we use your Pi Striker? So it's decided, Pi Striker V2. We can build it bigger, faster, stronger, less likely to be destroyed by adults who go too overboard. So we get some handymen in, we rebuild it with a stronger frame, we put a metal bar in there to stop it warping, and we decide one crazy thing. So Microsoft's brought out this new universal Windows platform. Let's rebuild it. Instead of with an Arduino, with a Pi running Windows 10. So, how'd it go? I'm going to show you a quick video of how that went. So we see there, the light show runs, and then when someone hits the mallet, it switches from a display mode into a play mode. And actually, when the screen is connected, we see the score goes up. And from all accounts, it was a massive success. But sadly, we never thought about transport. it turns out there's a whole lot of problems with IoT. And in the way back, some of the pins got damaged, and now the Pi Striker is sadly no longer operable. But it's not the end for Pi Striker. There will be V3. We will rebuild this again, I tell you. And what we're going to do this time is make use of that new Lightning driver Microsoft's been talking about. In the most recent patch, they brought a new driver out that's going to make the Pi run 100 times faster in certain cases. So we're going to try again using this new Lightning driver and see what we can create this time. So what is this universal Windows platform? So with Windows 10, Microsoft had a simple goal with their apps. The simple idea was, let's create one platform that you can leverage across multiple devices, ranging from their HoloLens all the way down to these IoT devices. And what they used as the base for this was the .NET Core. So effectively, the .NET Core, the same thing that's running ASP5, is now actually powering the IoT device as well, which means that C# you know and love, that await, that async, those NuGet packages you're used to using, they all just work. But as you will have seen before, it's not Windows like you know it. So for me, when someone says Windows, I think XP, because I was stuck there during the Vista days. No, instead, the Universal Windows Platform is a container, effectively. And what you're doing is you're deploying your application into it, and it runs nicely. So now we're going to quickly show you some of the hardware that's running Windows 10 IoT. So at the moment, the main focus of that IoT push is development boards. So this is hardware that's great for these small hacker projects. It's great to get up and running with, but you wouldn't put a Raspberry Pi in a product you're going to sell 1 million of. They are quite cost prohibitive. Now, the two most popular devices is the Raspberry Pi, the $35 1 gig of RAM quad-core little device, which is great for any of your general IoT projects. Works quite well for your Pi Striker, your Sonar, your little Drover. Or if you want to do like a smart e-kiosk, what you can do instead is you go with something like the Snapdragon. Now, a Snapdragon is a more expensive board. It's about $200. But it will get DirectX support. It has inbuilt Bluetooth and Wi-Fi. And it's the basis of some of those Android mobile phones, you know. So depending on the use case, will depend on what you use it for. From my own recent personal experiences, I found that, oh, come in please. I found that it's actually quite useful having a computer that only costs $35. My little brother was recently building himself a drone. And they're going to build an autopilot, so they attach all the sensors to the Pi, but they didn't properly ground it. So the drone takes off, and we start smelling burning plastic, which smells god-awful, as you can imagine. And we quickly grabbed the drone, we pulled it down, and we found that the actual board had melted. Somehow it had melted. So what we did, basically, we took the shield off the top, we grabbed the chisel and just smacked it off. We fixed the wiring problem and got another Pi. It's really nice having this idea of it's cheap and disposable. Like, you can throw it into all sorts of crazy situations. If it breaks, you just get another one. It's really quite nice to have this at your fingertips. So now with that, we're going to hop into the first demo, and I'm going to show you how to create a universal app. Hi, Adam. Cool. So first we're going to make a blank universal app. And we're going to call this, we'll call it Pi Weather. Now while this is spinning up, as you notice there, it showed that it had a number of different possible targets. And when you're building this, you're not actually saying, I want to run against a certain target. You're just saying, I want to build a universal application. So it comes straight up. Now, the first thing we need to do is make some kind of UI. So we can come into our main page.xaml. And normally you would get a designer. You don't want to really be writing this by hand. And that's something that's really important to know. If you guys jump into this today or tomorrow, you've got to come over here, right click, go into the properties, and change the setting from this 586 down to 240. So that's just a small bug at the moment with Visual Studio. And if you guys don't change that, you're going to lose access to your designer and have a little bit more trouble working with the platform. So if we hop back, we have our XAML. So the thing I really love about this, so I come back from those Windows 8 app days. They seemed like years ago. There's this really great drag and drop designer, which I then sadly miss again when I hop onto Xamarin. So if we go over here, the first thing you notice is that there are many different kinds of UIs we can target. So we're going to jump down and we're just going to show what it would be like as if this was showing on a 10-inch IoT device. So that's what you usually will be going against if you're using a Pi. And below, the 42-inch is more for using a Snapdragon or a bigger board. I find the Pi, you will get the infamous blue screen of death if you start trying to do too much. It falls over pretty quickly with media elements. So come in here and we'll go to text block. And we're just going to drag a few onto our screen. So the first thing to know is that we can just come in here and we have all our IntelliSense. So for example, you guys can't see those at the moment. I'm going to increase the font size. So F. So we'll increase the font size to 64. And the next thing we're going to do is we're going to set the names for these elements. So setting the names allows us to reference these elements on the XAML in the code. So effectively, we can then call against it, for example, the text block.text, and then change its contents. So it's really important we go and set the names for both these elements. So we'll set it to temperature and humidity. And I'm going to change, just for making this easy to keep a track of, I'm just going to change the text to humidity and temperature. Okay, so we've basically just knocked up a quick UI. And you're going to find that, especially using this tooling, it's really quite straightforward. If you want to do more in-depth design work, you can now use Blend as well to let you sort of manipulate it a little bit simpler. So up into Solution Explorer. Now with these apps, you've got to understand that there's a relationship between the XAML and the C#. And Visual Studio shows this by almost like a tree, like it's a layer underneath the C# code that links directly to that page. So we're going to scroll down here. Now, what should we do with this application? I think I've already given it away before with the UI. What we're going to do is we're going to make a simple weather app. So to do this, we need to get weather data from somewhere. And before we use the GPIO pins on the Pi, we're going to go get it from the cloud. So the first thing we need to think is what the data is going to come back as. And it's going to come back as JSON. So we need something to interact with JSON. Now, as a .NET developer, what package would you use? Anyone want to throw their hands up? Unsoft. And the best thing about the Universal Windows platform is we can just come over here, go Manage NuGet, we see Unsoft JSON on the front page, and we just click Install. It lets us use a lot of the packages we know and love to make our lives easy. So we're going to come over here and install Newtonsoft.json. And that's all it is to it. So before people started targeting universal applications, what you could do is you could actually use any package that was targeted against Windows Phone 8 or Windows App Platform 8 and above with your universal apps. So if a package seems dead, you don't have to worry because it still might work with the Pi. So all our packages have been restored. So how are we going to get some kind of class to deserialize our JSON from? And I'm pretty sure you guys might all know this trick already, but if we come over here and we click our API link, it'll take us to the page and it will give us some JSON. So let's open that up in Visual Studio Code. We're now going to copy this JSON into our clipboard. Now, a quick show of hands if people know what I'm going to do here with the pasting. No? So we come over here and we're just going to use our autocompletes to make this easy. We're going to say create us a new class and a new file for open weather data. And this is where Visual Studio has all these nice little things that make life easy for us without really introducing much more complexity. So we can use a thing called paste special and actually paste that JSON in as classes. So it's going to go read the JSON on our clipboard and generate the classes we would need to deserialize to it. As you can imagine, this saves a mountain of time when trying to work with JSON. So we do have to do a little bit of cleaning up. So we're going to delete this root object and just replace it with the open weather data. So there you see, we're using HTTP client, which if you've done any Xamarin, if you've done any Windows Phone 8 or recent development, you know that's our go-to and standard way of interacting with the web. And all we're going to do is just use Newtonsoft JSON to deserialize it and give us back our object. Now, there is one little trick to this. Anything that goes in this block here called the main page will run synchronously. And if you try and put the get data straight in there and then reference against it, you can get into some weird situations. So my little trick I say to people is always put a method in there. Just going to use my work completes, and then work from that method out. I find that saves a lot of the problems that people have when they're first starting off with this platform, is using this little trick here where you have a method in your main page that will run synchronously, but it's hiding away all the async stuff nicely for you. So instead, now I'm going to go var data equals get data. Now, of course, I have to await this method, and that will then complain that the method is not marked async. So asyncs and awaits, I love them. It's one of the main reasons I really do love using C# over C for Advanced. Just stuff like threading and the like, just it's so much easier in C#. So now I can go temperature.text. Because we've referenced that temperature before, we can access any of its properties from the code behind on the page. And now I'm just going to say data. Now this is one of those things, when you use someone else's weather station or when you use someone else's out and about their APIs, you have to respect their form. So for them, it's data.main.temperature.toString. And then I come down here and I'll just do the same for humidity. So I'm going to go humidity.text equals data.main.humidity.toString. That is always a mouthful. And now we can run this against our local machine. So one of the really nice things is, depending on what features you're using, you can actually just develop locally, test it, and then throw it over to the Pi or throw it over to the Xbox or whatever platform you are targeting. So you see there, we've gone and got the weather data from this weather API and now displaying it on the screen. So guess how many code changes it takes to make that work on the Pi? Any guesses? Yeah, you're right. So it does take 0 changes. So effectively what we're going to do is we'll come down, go ARM, and now we're going to hit remote device. Now if we're lucky, it's going to detect it, but sometimes it won't pick up. So I'm just going to go and grab the correct address. 182. So this is the thing called the IoT dashboard. Microsoft just brought out. Basically what it does is it acts as a hub for managing all your IoT devices. So we can see the mini Win PC, my Pi is talking to this laptop, and we can even go over here and open up in browser view of more settings, which we will come right back to. So it has my, no. So I'm just going to get the IP address. It's 192.168. 192.168.137. What is it? .119. Select, and we'll deploy out to that. So while that's deploying, I'm just going to quickly show you this web port. So from this, we can basically manage all of our preferences for the Pi. So for example, we can decide what applications start up first. We can also uninstall any apps from here and install app packages. So if you know someone who's made an awesome app and they give you the package file, you just chuck it on your own Pi. But really excitingly, we actually have the debugging and performance menus. So we can actually see in real time what's happening on the Pi, what memory's in use. So as you can imagine, this makes debugging a Pi's application a lot simpler, having this great telemetry directly in front of you in the web browser. And it's doing this because the Pi is actually running the universal app package sort of container-esque item and a web server at the same time simultaneously on the one device. So now if we switch over to the Pi, and it decides to wake up, we see we've got the exact same value. So it's gone off to the cloud, it's gone and got the data, and it's displaying it on our screen. So is there any questions? Cool, so we're going to move right on then.
What were the numbers in the corners?
Oh, numbers in the corners. So I get this every time. From memory, they're performance numbers with the number of frames being displayed and the like. So what happens is, I can never remember off the top of my head which number is which. If they go red, you're normally in trouble. So a Pi outfit you're pushing too hard, like for example, I tried transcoding entire HD video, had all my numbers go red, and then the Pi fell over and blue screen of death on me. Yeah, so it's just the remote debugger stuff, yeah. Cool, so what did we just do? We created a blank universal app, we made a UI, admittedly not as nice as this one, but that's still quite easy to knock together. We added the Newtonsoft JSON package, and it just worked. We went and we used that paste special command, one of the best kept secrets in Visual Studio, to just make our class for us without us having to lift a finger. And then we just wrote some code that really is just plain regular C#. It's the C# you know and love, but it just works across platforms. It's really quite magical. So what if I want to get the temperature in this room? I mean, I'm going to imagine it's a bit hotter here and a bit more humid, even with the air conditioner blazing. We're going to need to use a sensor. So in this chance, we're going to use the SparkFun weather shield. And what a shield is a collection of sensors. Now, the reason I really like the SparkFun is it gives us humidity, altitude, pressure, temperature, humidity, but it also lets us communicate with these sensors via a range of different interfaces. Furthermore, we can also expand this so that we can add GPS modules, rain gauges, wind sensors. You can imagine it's actually quite a powerful little sensor board. But how are we going to communicate? In order to communicate, we have to use something called an interface. And an interface is a predefined way to communicate across two electronic devices. Now, my personal favorite is I2C, and this is an example of I2C in use. So I2C has, we're going to say, a two-line bus. So the green and the blue lines. And effectively, one device acts as the master, and the rest of the devices are slave devices that the master controls. Now, you can have up to 120 slave devices linking to that two-line bus. So that two wires of connection can support a fair bit of devices. And how it roughly works is something like this. Each of those devices has an address. So we're going to imagine the Arduino has the address of 4 as a bytecode. The Pi wakes up and says out to the bus, is there someone sitting at number 4? And the Arduino comes back and says, yeah, I'm here. I'm ready and ready to go. Then the Pi sends out, okay, I have this command for you. And then it waits and listens for the response from that Arduino. So as you can imagine, this is quite powerful. And for those guys who can't see out the back how this is wired, we effectively are using a very similar setup with the two-line bus, power, but I had to supply some more power for this shield. It's cool. Now we're going to go over changing this code so that we use the GPIO sensors to get the data from the weather shield. Okay. So the first thing we need to do, to access the unique properties of the Pi, as it's part of the IoT family, we need to add the Iot Extension Sdk. So we do that by going add reference, we're going to come down to extensions, and this is something important to notice. Because I've gone and set to 1024, I also need to make sure I pick the 1024 Extension Sdk. And what this gives us is all the libraries and DLLs tied up with controlling GPIO controllers on an IoT device. So I'm going to now pull in a file I wrote earlier. I'm going to walk through it with you guys as an example of how to interface with this electronic device. So we'll add an existing item, we'll go documents, use group, SparkFun weather shield. Okay. So how this works is, first up, when we buy a sensor, these are freely available on the internet, there'll be documentation that comes with it. And we call these data sheets. So these commands at the top are from reading through the data sheet and finding out what commands lined up. For example, this sensor that I want to use on this shield circuit has an address of 4. And if I want to tell it to give me temperature or humidity, I have specific bytes I have to pass to it. So the first step, and just ignore this step, I'm going to come back to it, is we call Initialize. And all that Initialize does is it says, I'm going to go get the GPIO controller, I'm setting you up in I2C, I'm now going to go, and I know that this device exists, so I'm going to go and put the address in. I'm going to try and open the connection. set some properties, and then once it's happy, once it gets that, yes, I'm here, I can do stuff for you, it's going to give us back an object. And that object is going to wrap up a lot of the complicated stuff I just said in that earlier slide. So us as developers, we don't really need to understand the electrical engineering principles that are going on there. We don't really need to understand the I2C interaction. We just need to know how to initialize the connection and then call out to it. So for example in here, all we're going to do is we're going to do a command called a read-write. So what that means is we're going to first write out our command and then we're going to wait for the response and read it back. Now, for example, so we're going to call in we're going to write the humidity command, and when we get the data back, we're going to then have to validate it. So this is one little problem with using hardware devices like this. There can be some signal interference so that the data you get back is not the data that was intended to be sent. So to get around that, we're using a CRC check, the same kind of checks you're using on your zip files to make sure that they're not corrupted. And once we get that back, we run it through this formula, which they give you on the data sheet, to then convert it back from its raw value into a unit of measurement. And temperature is exactly the same. We write a command that's been predefined, we read it back, we validate it's right, and if it's right, we convert to units. So as you guys can see, it's a pretty straightforward pattern. We write, we read, validate, we show. So it's really easy to get your head around how this works and start using it as a .NET developer, even if you don't really understand what's going on as far as the electrical engineering side of it. So we're going to come back over here. So there is a little downside. Only one device can talk on the bus at one time. And in this case, with a simple example, we're pretty safe for that. I mean, our setup method will just ensure we're not getting to it early. If you were using multiple sensors on the shield or you want to do faster reads, you will need to set some mutexing up to make sure that you're not jumping in on someone else's write. As you can imagine, if you try and write when it's expecting a read and a read when it's trying to expect a write, it blows up in interesting and new ways. So just save yourself the smell of burning plastic and make sure you really control access to that bus. So we're just going to change this method and simply just change it for saying if, okay, should go first go up here and go var shield equals new sparkfun dot weather shield. So that was the class we made earlier, and what I'm going to say here is go await shield dot setup. And if this comes, when this comes back as true, we're going to just do the following. So we don't need this get data anymore. We're just going to put our curly braces around. And now we're not going to use that to serialize data. We're just going to get that property that we set earlier. So all we have to do is go, just delete this, is shield dot temperature dot to string. And again, the same with humidity. So we're just going to go, oh, sorry. Shield dot humidity dot to string. Now, what do you think is going to happen if we try and run this on just this laptop? So what will happen is it will pop up a file not found exception. So I'm just going to deploy that to the Pi. And the file not found exception is simply going to say, actually, I couldn't find the existence of a GPIO controller on this device that I can access, so I'm going to quit out. So one other point to notice is that the first time we deployed, it deployed a 12 meg package to the Pi. And now that we've gone and made changes, it's only going to do a partial update, which makes it a lot easier to keep deploying. And there's a few ways you can get around this if you want to clean it. So one, you can set in your project file recently saying uninstall any other package that comes from this before you install me, or just logging into that web portal, one click, you'll uninstall the package. And as we see, it just comes straight up. We're reading the values and we see, yeah, as per my thought, it was actually hotter in here than it is outside. So cool. So before we jump ahead, is there any more questions? Cool. So now, what do we do there? So just as a brief recap, we add an extension SDK when this comes up. We add the extension SDK. We first initialize the device based on information from the datasheet. We then went and we wrote data using the extension SDK to that shield, and we read back the contents. Once we had the contents, we wanted to make sure the data was valid, so we ran a CRC check over it. And then once we were satisfied that yes, the data didn't change in transit, we converted it to a regular unit for humidity. And once we had that, all we had to do was just await the setup and then call against its properties. So as you see, we've hidden away all that confusing IoT code that may scare some .NET developers behind simple properties. So now the temperature and humidity wrap that all up nicely. So the first time I gave this talk, someone hopped up and said to me afterwards, "You just shrank the universe." And the reason he said that was because now my universal app no longer worked on my desktop. And this becomes a bit of a problem. Imagine you're working with a guy in Belgium who loves beer, and he's decided to build an IoT kegerator. He is really happy about this idea. He's got all the parts. He started building the hardware, and he says, "Can you build me software?" Well, I don't have anything to test against. I don't have any way of running the application even. I don't even have anything to connect to my GPIO controllers. This problem then gets extended because we have the idea of device families. So certain features or functionality we may want to put in one part of our app, well, it might not exist in another platform. Now, although this isn't really a problem with IoT per se, it's going to be a bigger problem once the Xbox One becomes a UWP developable platform, and people are going to start going, "Oh, I want to build a mobile app that's going to run on desktop and Xbox." That's when this issue is going to really bite us quite hard. And so the solution is to use something called dependency injection. And the quick way of explaining that is we get rid of solid coupling. So we put in these things called interfaces. And how interfaces work is they act like power plugs. So seeing here, you would never actually directly solder a Pi to live wires. Instead, you'd have a plug and you simply plug it in. And then you might decide, well, I want to use that power plug for something else. So you unplug it and you plug something else in. And that's the great thing about dependency injection. It allows us to plug in code that will match a plug at any time and just switch between them. So that way we can then react between different platforms, allowing our application to work across them. So to do that, we're going to use a dependency injection container. So before I go on, who here is comfortable with dependency injection? So who here likes AutoFac? You all like AutoFac? Then let's use AutoFac. So yeah, AutoFac is my dependency injection container of choice. So I was hoping you would all like it as well, because I don't know any other one, sadly. I've always been an AutoFac guy. So you can use basically anyone. So I've played with TinyIOC on this, and it's worked well. And I've played with, is it Castle, the other one? Yeah, I've chucked Castle in there, and it worked without issues. So it seems like those couple will work nicely. I just haven't tried all of them yet because all my needs are filled by AutoFac. Yes, you can tell I'm a bit of a fanboy for it. So again, we just click install and it works as we would expect it to. And this is the great thing. We know how to solve these problems. We know how to solve dependency injection. We do it every day as .NET developers. We know how to deserialize JSON. Why can't we just use the tools we know well? And that's what that universal platform is giving you. It's letting you use those tools that you know how to use. So we're going to hop back over here. And just by our display method, my code's a bit. We're going to set up our new builder. And I think you all know how to use AutoFac, so I've just got to make a few little corrections. So for those who've never done this before, I really recommend using Resharper to make this simple. We're going to go into our Spark from Weather Shield. We're going to right-click, and what this is it's from Resharper, which is a great plugin that gives us extra refactoring and little helping options when we write code. We're going to go extract interface, and the trick is we're just going to click all public. And we'll place this into another file. And what this does is it looks at the plug we have, the prongs plug we have, and goes, what kind of wall socket do I need to fit that? And then it goes and works it out for us. It's doing all that hard work. So if we're just going to jump over, we see it's right there. So what could we switch out our dependent code with? We're going to make a new class that implements the SparkFun Weather Shield, and instead it's going to use the code we made in the first step, just going and getting the JSON and displaying it when we don't have GPIO controllers. So we're going to go and add another file, and we're just going to, because it's all code you've seen before in the earlier steps with the get data. So again, it's basically as you expect. So instead of initializing up an actual GPIO controller, we're just going to go get JSON, put it in there, and then return it as we expected. And the only little trick you have to know here is this one little block of code I'm about to show you. So, which is here. This version info.device families is a real lifesaver. So when this first came out, what people were trying to do was detect the existence of the IoT DLL, which ran us into all sorts of trouble. Because what would happen is people forgot that that DLL gets loaded onto any platform when you click that button. So what you've got to do instead is you actually go query the device and say, hey, which family do you belong to? And it will go, I'm either desktop, I'm IoT, I'm mobile, I'm Xbox. It will come back and tell you its family. So then to use it here, all we're going to do, I'm just going to display the other, switch through, is we're going to set up our shield with our lifetime scope and just do exactly what we did before. So what this is then doing is, at runtime, when we first start our app up, we're going to resolve back which is the right weather shield to talk to based on what we have at hand. And then in our code, we're just going to go and make up a weather shield and then call against it. So if we now run locally, we find it all will purr along quite nicely. Now the interesting thing is that we will see different results between both the IoT run and on the desktop because they're getting data from different sources. So 22 and 60, and now if we're going to stop this and we rerun against the Pi, it will take a brief moment to come up. So as you can imagine, that allows us all sorts of power. It allows us to work without really having physical hardware there, as long as we know what those interfaces are going to look like, which is great for teams who are in different countries or have limited funds for hardware. Cool. So we see we've got different values between the Pi, which is reading the local weather and temperature, and the weather station out somewhere else in Sydney. Cool, so just jump over. Let's run up. So what we do again, we made an interface. It's quite straightforward. We implemented that using the code we wrote in the first step. We added autofac. We added this nice little block of code that could detect which to plug in depending on device family. And then we simply used autofac like we normally do. We resolved back the scope and used the shield. So I've shown you a really nice desktop ornament, haven't I? Really, it's not Internet of Thing, it's Internet of Things. I've been reminded many times. So we're going to now talk to Azure. And the brilliant thing about Azure is it all talks REST. So that's really the secret here. You can start work using a Pi. You can start coming up with your ideas, you start developing it using your .NET skills, you rapidly get out your minimum viable product, or your backend talks REST. So the nice thing is that, let's say you crack it, let's say you have that next big idea. Then when you want to switch to Arduino or a different platform if you choose to, you can then go, well, I just need to talk REST back to my web services. You don't have to rewrite that. There's no need to couple yourself onto specifics because you're using this universal platform. So I'm just going to grab another method. Cool. So all this is basically doing is we're going to pump in the weather shield and it's going to send it off to the cloud. Now, I didn't bring down my GPS module with me. I find it misbehaves. So instead, we've got these values just been hard-coded in for tonight. So okay, why is that not liking it?
You mislead it by the brackets.
Will I miss it?
You need to scroll up. You deleted the bracket.
Did I?
So one of the getting stats.
Oh, there it is. Yeah, my bad. It's always so hard to see these little brackets, aren't they? Oh well. There always has to be something that goes wrong with code in demos. So again, we're going to just deploy it to the Pi. And it works exactly the way I've shown you. So it's all just using HTTP client. It's talking REST. It seemed a little boring because it's so straightforward. But it's letting us do really powerful things with small hardware and skills we already have. So this will start up. We're going to see our temperature. And then we're going to show you a visualization of that data. Okay, cool. So now all things going well and demo gods being on my side. When we go back here, so what I did earlier on today was I decided to sit down and I interfaced with a range of other weather stations around the world and put them onto this map. So we can see if we go and we hover over, that's the current temperature for Brisbane. And if we reload this weather map, we're going to see a new dot appeared, and that one there, Sydney, is our little Pi, sitting there and running. It's pumping data up to Azure via REST, and it's now interfacing with a number of other weather stations. So this has all been really straightforward, and I hope you guys really do jump into this platform. So thank you for your time tonight. If you have any questions, feel free to ask.